You're welcome to my YouTube channel. This is Solomon at Solo for Math. Today we want to look at Surds for A-level mathematics and O-level mathematics, Senior 5 work, Senior 3 work. Alright, Surds, these numbers that are Surd. Right, what is a Surd? A Surd is that number that cannot be expressed as a fraction of two numbers, or we say that they are generally irrational numbers, because a number that can be expressed as a fraction, like a half is a rational number because it is a fraction of two numbers. Now there are numbers like a square root of 2. If you press it on your calculator, you end up with something like 1.414214 and so on. And this cannot actually be expressed as a fraction. There is no way. You can try changing this to a fraction. It is impossible in a way. So such numbers that we cannot express as fractions of two numbers are the ones that we call surds. So we want to start by looking at how we can simplify surds. Simplifying surds. To simplify meaning we are going to see how we can write the surds in another way. What we need to notice, if you have a root of, for example, a, b, a product and a root, then this one we expand it as square root of a times the square root of b. So in simplifying surds, we are going to realize that we express the number under the root as a product of two numbers, and one of those numbers should have a perfect square root. Let's look at an example. For example, if you have a root of 8, this one is a surd because it has no perfect square root, and we cannot express it as a fraction of two numbers. So how can we simplify it? So find two numbers in which you can write 8, so that one of those numbers should be having a perfect square root, and then of course multiplied with the other number. So I can say that 8 is equal to 4 times 2. So I can now say that a square root of 8 is the same as a square root of 4. Just substitute 8 for this. It is 4 times 2. Now using this rule here, we said we can separate this to give us square root of 4 times the square root of 2. And what is the square root of 4? It is a 2 times root 2, which we can write as 2 root 2. That is how we can simplify these surds. And if we look at another example, if you have a square root of 60, how can we write 60 as a product of two numbers, with one having a perfect square root? 60, I think I can write it as a 4 times a 15. So if we have that, then it means I can write a square root of 60 as a square root of 4 times 15. Expanding this will give me a square root of 4 times the square root of 15, which is a 2 times root 15, and giving you 2 root 15. In most cases, when you write something like this, 2 root 15 is like there's multiplication here. Yeah, shouldn't be confused about that. Yeah, maybe one more example. If you have a square root of 5, 1, 2. So this one we can express it as a square root of 256 times 2, which is the same as the square root of 256 times the square root of 2, and the square root of 256 is 16 times root 2, which gives us 16 root 2. Yes, that is about simplifying. There are other questions about simplifying. For example, they can ask you to simplify a square root simplify square root of 8 plus square root of 18 minus 2 square root of 2. How can we handle this? So what we do, simplify like we've been doing here. What is root 8? Root 8 is the same as is equals to root 8, which is the same as a 4 times a 2, plus what is root 18? Root 18 is the same as 9 times a 2, minus this is it to its simplest form, and when we expand this is the same as root 4 times root 2 plus root 9 times root 2 minus 2 root 2. This will give us a 2 root 2 plus a 3 root 2 minus a 2 root 2. Since they are all having root 2, so like this is like 2 plus 3, which gives us 5 root 2 minus 2 root 2. Now again, they're still having the same, so we can subtract, giving us a 3 root 2. Okay. Or from this point here, you could just factor out a root 2 because it was common, and then what remains here, remain with the 2 here, remain with the 3 here, remain with the 2 minus 2 here, the root 2 outside. And then when we simplify what is in the bracket, this is 5 minus 2, giving us a 3 root 2. What we have here. Okay. Another example. If you're asked to simplify square root of 75 plus 2 root 12 minus root 27. So we can say this is equal to, simplify these surds, that is 75, which is the same as 25 times 3, 5 as a perfect square root, plus 2, 12 is the same as a 4 times a 3, minus 27 is the same as a 9 times a 3. Okay, so this one is the same as square root of 25 times square root of 3 plus 2 times square root of 4 times square root of 3 minus square root of 9 times square root of 3. and this one gives me the square root of 25, which is a 5 root 3, plus this will be a 2 times square root of 4, which is a 2 times a root 3, minus root 9 is a 3 root 3. Okay, so when we simplify further, this will be square root of 5 square root of 3, plus this is a 4 square root of 3 minus a 3 square root 3. We can factor out root 3 because I see it is common, so we shall remain with 5 plus a 4 minus a 3 into root 3. On simplifying, this is 9 minus a 3, which is a 6 root 3, and it is simplified as you see. Alright, we want to look at what we call rationalization of surds. To rationalize is to remove a surd from a denominator of a fraction. It is not advisable to write a surd in the denominator. For example, if you have 1 over root 2, it's advisable that you take away this root 2 from the denominator. How do we do that? And the process is what we call rationalization. So what we do, like in this case, this one is a bit simple. What you do, multiply by this surd in the numerator and in the denominator. Okay, and when we do this, this will give us 1 times root 2, it remains root 2 over this one. If we go backwards, remember the other where we had like square root of a times b is equal to square root of a times square root of b. Okay, so even here, if we have this, then we can take it back here, so it's like we're having the square root of 2 times 2, which is equal to square root of 2 over the square root of 4, which gives us the square root of 2 over a 2. Okay, so when we have such, that is what you can do. Maybe another example here. When you have, for example, a square root of 1 over 3, we know this square root is shared by the numerator and the denominator, so this is the same as square root of 1 over square root of 3, which is equal to 1 over square root of 3. Now, rationalize, multiply by what is in the denominator, which is root 3, in the numerator and also in the denominator. We do this just such that we don't change the expression. So, you see that will finally give us root 3 in the numerator over this one. We can also interpret it like a square root of 3 squared, because this is the same as this. So when you multiply, then it's like we are multiplying root 3 twice, which is this, and it will give us root 3 over a 3. Okay, maybe one more example about that. If you have 2 over root 5, this one we do the same, multiply by the denominator in the numerator and in the denominator, so root 5 over root 5, and this will give you a 2 root 5 in the numerator over square of this, which gives us 2 root 5 over the 5. So you see at the end we don't have any surd in the denominator. Alright, now there are other cases that we have. Cases like they ask you to rationalize. Rationalize maybe 1 you have 1 over 3 minus root 2. So in this case we are going to talk about what we call a conjugate. So what we do, we multiply by the we multiply the numerator and the denominator by the conjugate of this denominator. So the conjugate, how do we get the conjugate? Just change the sign here. Okay, just change the sign that is in the middle, so you have 3 plus root 2. That is the conjugate of this, of the denominator. So we multiply it in the numerator and in the denominator. So meaning 1 over 3 minus root 2 is equal to 1 over 3 minus root 2. Multiply in the numerator by the conjugate, which is a 3 plus root 2 over 3 plus root 2. So in the numerator we shall have 3 root 2, 3 plus root 2 over the denominator, it will be 3 minus root 2 into 3 plus root 2. So we have to simplify it. You clearly see that in the numerator we have something like a difference of 2 squares. When, for example, you have a minus b into a plus b, we say this is the same as a squared minus b squared. Difference of 2 squares. When you expand this, it will give you this. So you can say this is like our a, this is like our b. It appears also here. So meaning we are going to relate it to this, so we shall square 3 and also root 2. And we end up with the numerator remains as that over 3 squared minus root 2 squared. So this will be equal to 3 plus root 2 over 9 minus a2, giving us 3 plus root 2 over 7. You see, finally we don't have any surd in the denominator. Last example, let B, if you have square root of 5 plus 1 over square root of 5 minus 1. Rationalize. What is the conjugate in this case? Conjugate, we get the conjugate of the denominator. We just change the sign here, the sign of the surd in the denominator. So we shall multiply by root 5 plus 1 over root 5 plus 1. Just change the sign here in the middle, and this will give us like root 5 plus 1 squared over, and we say this will always be a difference of two squares, so just square this. This will always be a difference of two squares in the denominator. So when we expand the numerator to give us root 5 squared plus 2 root 5 plus 1 squared over, in the denominator we have 5 minus 1, giving us this is a 5 plus this one here plus 2 root 5 over f, and that one is equal to, we have a 6 plus a 2 root 5 over 4. We can reduce by 2, this will be a 3, by 2 this will be a 1, this will be a 2, so remain with 3 plus root 5 over 2, and that is the answer. So those are surds. If you've liked this video, if you've enjoyed it, share it with a friend. Don't forget to subscribe. Thank you for watching.